In this lecture we'll answer two questions. In the first question we find out the value of line segment X that is inside rectangle ABCD. In the second question we find out the value of the green shape that is inside this semicircle. Okay, so we start with the first question. In the drawing we have rectangle ABCD. Inside rectangle ABCD we have this circle. We know that the length of the tangent from point A to this circle is 33 units. The length of the tangent from point B to this circle is equal to 85 units. The length of the tangent from point C to this circle is unknown. This is the line segment that we are looking for. So we are looking for the length of the tangent from point C to this circle that is equal to x. So we have to find out the value of x, and finally the length of the tangent from point D to this circle is 35 units. Again, our mission is to find out the length of the tangent from point C to this circle that is equal to x. Okay, so first of all we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point P to this circle as F. We define the point of tendency of the tangent from point C to this circle as T. And we define the point of tendency of the tangent from point D to this circle as M. We join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself. Therefore, OE is the radius of this circle that we define as R. So OE equals to R. And we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB. Tangent AB is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of the tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to the radius MO. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 1. We can implement rule number 1 in our drawing. Why? Because here in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join point O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself. Therefore, OF is the radius of the circle that is equal to R. And again, we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Likewise, we join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle that is equal to R. And we have the radius OT that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. And finally, we join points O and M together by a straight line. Again, point O is the center of the circle, point M is the point of the circle itself, therefore this angle will be equal to 90 degrees according to rule number 1. Okay. In the next step, we join points A and O together by a straight line. So here, by joining points A and O, we create here the right triangle, triangle AOE. So we actually implement the Pythagoras theorem on the right green triangle, triangle AOE. Okay, so in the green right triangle, triangle AOE, according to the Pythagoras theorem, by PT is the variation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle is AO. Therefore, the square of the hypotenuse is AO square. And it must be equal to the sum of the square of the perpendiculars, that is to say, it must be equal to OE square plus AE square. Repeat again, in the right green triangle, triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given us in the question, therefore AE square will be equal to 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we join points P and O together by a straight line. And we will implement the Pythagoras theorem on the right yellow triangle, triangle OFB. So My PT is evaluation from Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the yellow triangle is OB, therefore the square of the hypotenuse is B all square. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OF square plus FB square. So I found out that according to the Pythagoras theorem, in the yellow right triangle, in the yellow right triangle, B all square equals to OF square plus FB square. Okay, so B all square equals to OF square. OF equals to R, therefore OF square is R square plus FB square. FB equals to 85 units according to what is given as the question, therefore FB square is 85 square. So in conclusion, according to the question number 2, found out that B all square equals to R square plus 85 square. In the next step, we join points O and C together by a straight line. And we will implement the Pythagoras theorem on the right orange triangle OTC. I'll repeat again. We will implement the Pythagoras theorem on the right orange triangle, triangle OTC. According to the Pythagoras theorem, in the orange right triangle, OC all square equals to OT square plus TC square. So CO square equals to OT square. OT is R, therefore OT square is R square plus TC square. TC is the missing 9 second, the 9 second that we are looking for. It is equal to X, therefore TC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. Okay. In the next step, we will join points O and D together by a straight line. And we will implement the Pythagoras theorem on the right pink triangle, triangle OMD. implement the Pythagoras theorem on the right pink triangle, triangle OMD. According to the Pythagoras theorem, we get that dO squared equals to OM squared. OM, it is actually the radius, is of course the radius of the circle, so it is OM squared, CD, again OD squared equals to OM squared plus MD squared. Repeat again. In the pink triangle OMD, according to the Pythagoras theorem, OD squared equals to OM squared plus MD squared. So dO squared equals to OM squared. OM is R, therefore OM squared is R squared plus MD squared. MD is 35, therefore MD squared is 35 squared. So in conclusion, we found out that according to equation number 4, dO squared equals to R squared plus 35 squared. In the next step, I will copy the 4 equations that we found according to the Pythagoras theorem in a new page. So we have here equation number 1 that states that according to equation number 1, AO squared equals to R squared plus 33 squared. And we have equation number 2 here that states that BO squared equals to R squared plus 85 squared. And according to equation number 3, CO squared equals to R squared plus X squared. And finally, according to equation number 4, dO squared equals to R squared plus 35 squared. So those are the 4 equations that we got from Pythagoras theorem. In the next step, I will copy triangle I will copy rectangle ABCD with its circle inside it, and we analyze rectangle ABCD. So we have rectangle ABCD in the circle. So this is actually rectangle ABCD with the circle inside it. We know that in any rectangle, all the four angles inside the rectangle are right angles, so this angle equals to 90 degrees. This angle, it is also equals to 90 degrees. This angle equals to 90 degrees. And this angle, it is also equals to 90 degrees. In the next step, from the center of this circle, that is to say from point O, from point O we go perpendicular on AB. From point O we go perpendicular on AB. So actually this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as T. But because of the fact that side AB of rectangle ABCD is parallel to side DC, it means that the perpendicular from point O on AB must be also perpendicular to DC. Why? Because AB is parallel to DC. So here this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees. We define the touching point of the perpendicular from point O and DC as M. In the next step, from point O, we go perpendicular on BC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as H. But because of the fact that side BC is parallel to side AD, it means that the perpendicular to BC must be also perpendicular to AD, because AD is parallel to BC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the rule that I mentioned. We define the touching point of the perpendicular from point O and AD as point S. Okay, so here inside quadrilateral ATSO we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 270 degrees plus 90 degrees, it is 360 degrees. That is the sum of the angles in any quadrilateral. Likewise, in quadrilateral SODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the same rule. In quadrilateral TBOH, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And finally, in quadrilateral OHCM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Okay, we define side AS as H1. We define side SD as H2. We define side AT as B1. we define side TB as B2, and we know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to those 4 small quadrilaterals that has 4 angles. Each quadrilateral has 4 angles inside it. Therefore, those 4 quadrilaterals, we relate to those 4 quadrilaterals as rectangles, because they have 4 right angles. So in rectangle ATSO, in this rectangle, the opposite sides are equal to each other. That is to say, side AT equals to side SO. But we know that AT equals to B1, therefore SO must be also equal to B1. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that side AS equals to side TO. But AS equals to H1, therefore TO must be equal to H1. Okay? So in rectangle SODM, in this rectangle, the opposite sides must be equal to each other. That is to say, side SO must be equal to side DM. But we know that SO equals to B1, therefore DM must be also equal to B1. Likewise, SD must be equal to OM. But we know that SD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBOH, side TO must be equal to side BH. But we know that TO equals to H1, therefore BH must be also equal to H1. Likewise, according to the sum of the opposite sides of a rectangle are equal to each other, we get that TB equals to OH. But we know that TB equals to H2, therefore OH must be also equal to H2. Likewise, according to the sum rule, in rectangle OHMC, side OH must be equal to side MC. But we know that OH equals to H2, therefore MC must be also equal to H2. And finally, in rectangle OHMC, side OM must be equal to side HC. But we know that OM equals to H2, therefore HC must be also equal to H2. So in the next step, we will join points A and O together by a straight line. And we will implement the Pythagoras theorem on the green right triangle, triangle OTC. On the green right triangle, triangle OTC, according to the Pythagoras theorem, we get that AO square equals to B1 square plus H1 square. Repeat again, in the green right triangle, triangle AOT, we get that AO square equals to B1 square plus H1 square. Likewise, we will join points O and B together by a straight line. And we will implement the Pythagoras theorem on the yellow right triangle, triangle OBT. According to the Pythagoras theorem, in the yellow right triangle, triangle OBT, BO square equals to B2 square plus H1 square. I'll repeat again. In the yellow, right triangle OTB, according to the Pythagoras theorem, B0 square equals to B2 square plus H1 square. We join points O and C together by a straight line. And we will implement the Pythagoras theorem on the orange right triangle OMC. On the orange right triangle OMC, according to the Pythagoras theorem, we get that CO square equals to actually here we know that rectangle TBOH, the opposite sides are equal to each other. That is to say, side TB equals to side OH. But TB equals to B2, therefore OH must be also equal to B2. And in rectangle OHMC, side OH must be equal to side MC, but we just right now found out that OH equals to B2, therefore MC must be also equal to B2. Okay. So, in the orange triangle OMC, in the orange triangle OMC, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. I'll repeat again. In the orange triangle OCM, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. And finally, we join points O and D together by a straight line. And we implement the Pythagoras theorem on the pink right triangle ODM. The pink right triangle ODM, according to the Pythagoras theorem, DO square equals to H2 square or B1 square plus H2 square. I'll repeat again. In the pink triangle ODM, according to the Pythagoras theorem, d whole square equals to b1 square plus h2 square. Again, in the pink right triangle, d whole square equals to b1 square plus h2 square. So here we have 8 equations. We have two different expressions for a whole square. We have two different expressions for b whole square. We have two different expressions for c whole square. And we have two different expressions for d whole square. Okay, so we will create 4 other equations. So the first equation that we'll create states that a whole square, according to this expression, the first equation, must be equal to a whole square according to the second equation. That is to say, r square plus 33 square must be equal to a whole square according to this expression, that is equal to b1 square plus h1 square. Okay, in the next step, we will create the second equation that states that b whole square according to the first equation must be equal to b whole square according to the second equation. So b whole square according to the first equation is r square plus 85 square. And it must be equal to b whole square according to the second equation, that is actually b square plus h1 square. In the next step, we create equation number 3. According to equation number 3, c whole square according to this first equation must be equal to c whole square according to the second equation. So c whole square according to equation number 1 is r square plus x square. And it must be equal to c whole square according to the second equation, that is actually equals to b square, b2 square plus h2 square. And finally, we create equation number 4 that states that d whole square according to the first equation must be equal to d whole square according to this second equation. So d whole square according to the first equation, this equation is r square plus 35 square. And it must be equal to d whole square according to the second equation, that is actually b1 square plus h2 square. So actually, this is the 4 equations that we created from those 8 equations. In the next step, we'll subtract equation number 1 from equation number 2. So it is equation number 2 minus equation number 1. In equation number 2, in this side of equation number 2, we have r square plus 85 square minus equation number 1. In equation number 1 we have minus r squared plus 33 squared, and it must be equal to here we have actually in equation number 2 we have here b2 squared plus h1 squared. So we have in the other side of equation number 2 b2 squared plus h1 squared minus equation number 1 we have here minus b1 squared plus h1 squared. So this will be equation number 5. We'll open the brackets of this equation number 5, and we get that according to equation number 5, so we'll open the brackets here, r squared plus 85 squared. So we have minus before the bracket, so here it will be minus r squared minus 33 squared equals to b2 squared plus h1 squared. We have minus before the bracket, so it is minus b1 squared minus h1 squared. So in this side of equation number 5 we have r squared minus r squared, that is 0, so r squared will get cancelled. On the other side of equation number 5 we have h1 squared minus h1 squared, that is 0, so h1 squared will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? In this side of the equation we have left only with 85 squared minus 33 squared. And the other side of equation number 5 we left with only b2 squared minus b1 squared. So according to equation number 5 we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step we subtract equation number 3 from equation number 4. So it is equation number 4 minus equation number 3, and we will get here that so in equation number 4 we have here r squared plus 35 squared minus equation number 3. In equation number 3 we have minus r squared plus x squared. We finish with this side. Now we get to the other side of equation number 4. In equation number 4, in the other side we have b1 squared plus h2 squared minus equation number 3 we have here minus b2 squared plus h2 squared. In the next step we'll open the brackets of this equation number 6, and we get that according to equation number 6 we have here r squared plus 35 squared. We have minus before the bracket, so it is minus r squared minus x squared, that is equal to b1 squared plus h2 squared minus b2 squared minus h2 squared. So here in this side of equation number 6 we have r squared minus r squared is 0, so r squared will get cancelled. In the other side of equation number 6, we have h2 squared minus h2 squared is 0, so h2 squared will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? In this side of equation number 6, we left only with 35 squared minus x squared, that is equal to b1 squared minus b2 squared. In the next step, we will multiply this equation number 6 by minus 1, and we get that according to equation number 6, minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, that is equal to minus b2 squared times minus 1 is plus b2 squared, b1 squared times minus 1 is minus b1 squared. So we found out that according to equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. While according to equation number 5, we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we create equation number 7. According to equation number 7, b2 squared minus b1 squared according to equation number 1 must be equal to b2 squared minus b1 squared according to equation number 6. So, repeat again. According to equation number 7, b2 squared minus b1 squared according to equation number 1 is 85 squared minus 33 squared, and it must be equal to b2 squared minus b1 squared according to equation number 6, that is equal to x squared minus 35 squared. So we found out that according to equation number 7, 85 squared minus 33 squared equals to x squared minus 35 squared. Here we'll add 35 squared to this equation number 7, and we'll get that according to equation number 7, 85 squared plus 35 squared minus 33 squared equals to x squared. 85 squared is 7,225 plus 35 squared. 35 squared is 1,225 minus 33 squared. 33 squared is 1,089, and it is equal to x squared. So here 7,225 plus 1,225 is 8,450 minus 1,089 equals to x squared. And 8,450 minus 1,089, it is equal to 7,361, that is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. Here we take a root out of this equation number 7, we will get that according to equation number 7, x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x. One is a positive solution, and the other one is a negative solution. And because of the fact that x is a length, x as a length, it must be a positive number, therefore we take into account only the positive solution. That is to say, we found out that x equals to the positive square root of 7,361, it is plus 85.769 units. Okay, and check it again. The square root of 7,361 equals to 85.796. Again, x equals to the positive to plus 85.796 units. So we found out that the length of line segment X, the line segment that we are looking for, the length of this line segment X equals to 85.796 units. So we finish with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. So in the drawing, we have a semicircle. Inside this semicircle, we have the green shape. We know that angle BAC equals to 30 degrees, AB equals to 6 units, AB is actually the diameter of the semicircle, and is equal to 6 units. Our mission is to find out the area of this green shape. So first of all, we will define the center of the semicircle as O. We know that the diameter of the semicircle is AB, that is equal to 6 units. Therefore, the radius must be equal to half of it. 6 over 2 is 3. Therefore, that is to say, here AO, that is the radius of this semicircle, will be equal to 3 units. And the radius OB of this semicircle will be also equal to 3 units. We join points O and C together by a straight line. Point O is the center of the circle, point C is the point on the circle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. So, in triangle AOC, this triangle, side AO equals to side OC. Both sides are equal to 4 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. We know that in triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees. And we know that the sum of the angles in any triangle is 180 degrees, therefore the missing angle must be equal to 120 degrees, because 120 degrees plus 60 degrees, it is 180 degrees. So this angle must be equal to 120 degrees. What is the area of a sector. If we have here we have sector A or B, it could be any sector. This is sector OAB. We know that the two legs of the sector, that is to say OA and OB, they are equal to R, that is the radius of the circle that contains the sector, and the angle between the legs of sector OAB, that is to say the angle between OA and OB is theta. Then the area of this sector, sector OAB, here, the rounded line here is the sign of the area of sector AOB. This means the area of sector OAB will be equal to pi r squared, that is the area of the entire circle, times theta, that is the angle between the legs of sector AOB, over 360 degrees. Okay, and explain the equation, the formula. Here, the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and when we multiply the percentage by the area of the entire circle, that is pi r squared, we get exactly the area of this sector. Okay, so the relative percentage that the sector occupies out of the entire circle times the area of the entire circle, that is pi r squared, is equal to the area of sector A or B. We'll implement the new formula in order to find out the area of this sector, sector A or C. The area of this sector, sector A or C. Okay, so I'll copy sector A or C in the new page, and we will implement the new formula in order to find out the area of this sector, sector A or C. So this is actually sector AOC that I copied from the original drawing. This is sector AOC. The length of the two legs is 3 units. That is the radius of the semicircle that contains the sector AOC, and the angle between the legs is 120 degrees. Therefore, according to the new formula, the area of this sector, sector AOC, will be equal to pi r squared. R equals to 3 units, therefore pi r squared is pi times 3 squared times theta over 360 degrees. Theta is the angle between the two legs, that is 120 degrees over 360 degrees. 3 squared is 9, and so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3, so it is 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we actually found out that the area of sector AOC the area of this sector equals to 3 pi square units. 3 pi square units what is the area of triangle AOC? So I'll present to you a new formula for the area of any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. We know that the length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle ABC will be equal to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC equals to A times B times sinus theta over 2. We'll use the new formula in order to find out the area of triangle AOC. So I'll copy triangle AOC in the new page and we'll implement the new formula in order to find out the area of triangle AOC. So this is actually triangle AOC that I copied from the original drawing. The area of this triangle AOC according to the new formula will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have 9 times square root of 3. In the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of this triangle AOC is equal to 9 times square root of 3 over 4 square units. Okay. But what is actually the area of the green shape? The area of the green shape, it is very easy to see from the drawing that it is equal to the area of sector AOC minus the area of triangle AOC. So I write it down. The area of the green shape equals to the area of sector AOC the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC, that is 9 times square root of 3 over 4 square units. Okay. Okay, so in conclusion, I found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers it is equal to 5.53 square units. We finish with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. So, according to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it will be equal to pi r square over 2. Pi r square over 2. And here r equals to 3, so r square is 3 square. So it is pi times 3 square over 2. 3 square is 9, so it is 9 pi over 2. In conclusion, we found out that the area of the semicircle equals to 9 pi over 2 square units. And again, the area of the semicircle equals to 9 pi over 2 square units. In the next step, we find out the area of sector COB. What is the area of sector COB? First of all, we find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the size of this angle. In total, they must be equal to 180 degrees. So here The missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees, because 120 degrees plus 6, 120 degrees plus 60 degrees equals to 180 degrees. That is the sum of the angles on one side of a straight line. So we found out that the angle between the legs of sector COB is 60 degrees. So I'll copy sector COB in a new page, and we'll find out the area of this sector COB. So this is actually sector COB that I copied from the original drawing. We know that the area of any sector is equal to pi r squared times theta over 360 degrees. We use this formula in order to find out the area of this sector COB. So the area of sector COB, according to this formula, it is equal to pi r squared, but r equals to 3, so it is pi times 3 squared times theta over 360 degrees. Theta equals to 60 degrees, so it is 60 degrees over 360 degrees. 3 squared is 9, so it is, this expression in total equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. We divide both the numerator and the denominator by 3. 9 over 3 is 3, so in total this expression equals to 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of sector COB, it is equal to 3 pi over 2 square units. Repeat again, the area of this sector COB equals to 3 pi over 2 square units. Okay? And I repeat on the formula for the area of our green shape. The area of our green shape, according to the second method, it is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay, so the area of the green shape according to the second method will be equal to the area of the semicircle, and we have already found out that the area of the semicircle equals to 9 pi over 2. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COB equals to 3 pi over 2 square units. So here we have 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4 square units. So we actually found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. So actually we finished with the second method and the second question. In the next step I will summarize the lecture. We'll start with the first question, of course. In the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle. We know that the tangent from point A to this circle equals to 33 units in its length. We know that the tangent from point B to this circle equals to 85 units in its length. We are looking for the tangent from point C to this circle. That is the unknown tangent, so it is equal to x. And we want to find out the value of x. That is the tangent from point C to this circle, or the length of line segment CT. And we also know that the tangent from point D to this circle, that is to say dm, equals to 35 degrees. Again, our mission is to find out the value of line segment CT that is equal to x according to what is given as the question. So first of all, we defined the center of this circle as point O. Then we have here the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. We have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. And finally, we have the radius OF that is also drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Then we joined points A and O together by a straight line. In this way, we created the green right triangle, triangle AOE. The green right triangle, according to the Pythagoras theorem, AO square equals to OE square plus AE square. I repeat again, in the green right triangle, AO square equals to OE square plus AE square. So AO square equals to OE square. OE equals to R. Therefore, OE square is R square plus AE square. A equals to 33 units according to what is given as the equation. So AE square is 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. Then we joined points O and B together by a straight line. In this way, we created the yellow right triangle BOF. In the yellow right triangle BOF, according to the Pythagoras theorem, BO square equals to OF square plus FB square. I'll repeat again. According to the Pythagoras theorem, in the yellow right triangle, BO square equals to OF square plus BF square. BO square equals to OF square. OF equals to R, therefore OF square is R square plus FB square. FB equals to 85 according to what is given as the equation, therefore FB square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Then we joined points O and C together by a straight line. In this way, we created the orange triangle, the orange right triangle, triangle OTC. In the orange right triangle, triangle OTC, according to the Pythagoras theorem, OC square equals to OT square plus CC square. Again, OC square equals to OT square plus CC square. Repeat again. In the orange triangle OTC, according to the Pythagoras theorem, CO square equals to OT square plus TC square. So CO square equals to OT square. OT equals to R, therefore OT square is R square plus TC squared. TC equals to X, therefore TC squared is X squared. So in conclusion, I found out that according to equation number 3, CO squared equals to R squared plus X squared. Finally, we joined points O and D together by a straight line, and we implemented the Pythagoras theorem on the pink right angle OMD. According to the Pythagoras theorem, OD squared equals to OM squared plus MD squared. Again, OD squared equals to OM squared plus MD squared. So OD squared equals to, or DO squared equals to MO squared. MO equals to R, therefore MO squared is R squared plus MD squared. According to what is given as the equation, MD equals to 35 units, therefore MD squared is 35 squared. So in conclusion, we found out that according to equation number 4, OD squared plus R squared equals to 35 squared. Okay, so here I copied the 4 equations that we got from the Pythagoras theorem. Those are the 4 equations that we derived from the Pythagoras theorem. Then I copied rectangle ABCD here. This is rectangle ABCD. Inside rectangle ABCD we have the circle. The center of the circle is at point O. From point O we do perpendicular on AD. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that in rectangle ABCD side AD is parallel to side BC, it means that the perpendicular to AD must be also perpendicular to BC. Why? Because AD is parallel to BC. So here this angle also equals to 90 degrees and this angle equals to 90 degrees according to the rule that I mentioned. We define the touching point of the perpendicular from point O and we see as H. We define the touching point of the perpendicular from point O and AD is point S. Then from point O we do perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that side AB is parallel to side DC in rectangle ABCD, the perpendicular to AB must be also perpendicular to DC again because AB is parallel to DC. So here this angle also equals to 90 degrees and this angle equals to 90 degrees according to the rule that I mentioned. We define the touching point from the perpendicular from point O and BDC as M. We define the touching point of the perpendicular from point O and AB as T. Then in quadrangle ATSO we have 1, 2 3 right angles. The sum of 3 right angles is 270 degrees plus the fourth angle. In total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore this angle must be equal to 90 degrees. Why? Because 270 degrees plus 90 degrees it is 360 degrees. That is the sum of the angles in any quadrangle. So this angle must be equal to 90 degrees. Therefore actually inside quadrangle ATSO we have 4 right angles. So therefore quadrangle ATSO is a rectangle. Likewise, in quadrangle SODM, we have 1, 2 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the same rule. Therefore, quadrangle SODM is a rectangle. Likewise, in quadrangle TBOH, we have 1, 2 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle TBOH is a rectangle. And finally, in quadrangle OHCM, we have 1, 2 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle OHMC is also a rectangle. So we have here, inside rectangle ABCD, we have 4 small rectangles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ATSO, here, but before that, we define side AS as H1, we define side SD as H2, we define side AT as B1, and we define side TB as B2. Then we focus on rectangle ATSO. In this rectangle, the opposite sides are equal to each other. That is to say, AT equals to SO. But we know that AT equals to B1, therefore SO must be equal to B1. Likewise, in rectangle SODM, the opposite sides are equal to each other. That is to say, SO equals to DM. But we know that SO equals to B1, therefore DM must be also equal to B1. Likewise, SD equals to OM, but we know that SD equals to H2, therefore OM must be also equal to H2. Here, according to the same rule, AS equals to TO, but AS equals to H1, therefore TO equals to H1. Then in rectangle TBOS, TB equals to OH, but we know that DB equals to B2, therefore OH must be equal to B2. Likewise, TO equals to BH, but we know that TO equals to H1, therefore BH must be also equal to H1. In rectangle OHMC, OH equals to MC, but we know that OH equals to B2, therefore MC must be also equal to B2. And finally, OM equals to HC, and we know that OM equals to H2, therefore HC must be also equal to H2. Then we join points A and O together by straight line. In this way, we created the right rectangle ATO. We implemented the Pythagoras theorem on the right rectangle ATO. In this right rectangle, AO square equals to B1 square plus H1 square. Again, AO square equals to B1 square plus H1 square. Then we join points O and B together by straight line. In this way, we created the right yellow triangle, triangle TBO. In the yellow right triangle, OB square equals to B2 square plus H1 square. I'll repeat again. In the yellow right triangle, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. Then we joined points O and C together by straight line. In this way, we created the orange right triangle, triangle OMC. In the orange right triangle, CO square equals to B2 square plus H2 square. I'll repeat again, CO square equals to B2 square plus H2 square. And finally, we joined points O and D together by straight line. In this way, we created the pink triangle or the pink right triangle ODM. The pink right triangle ODM, according to the Pythagoras theorem, OD square equals to DM square plus OM square, or OD square equals to B1 square plus H2 square. I repeat again, DO square in the pink right triangle, DO square equals to B1 square plus H2 square. So we have two different expressions for AO square, we have two different expressions in the equations for BO square, we have two different expressions for CO square, and we also have two different expressions for DO square. So therefore, we created equation number 1. According to equation number 1, AO square, according to this first equation, must be equal to AO square according to the second equation. That is to say, R square plus 33 square must be equal to B1 square plus H1 square. Okay. Equation number 1 states that R square plus 33 square equals to B1 square plus H2 square. Then we created the second equation. It states that BO square according to equation number 1 must be equal to BO square according to equation number 2. That is to say, R square plus 85 square equals to B2 square plus 1 square. Repeat again, according to equation number 2, we found out that r square plus 85 square equals to b2 square plus h1 square. Then we created equation number 3 that states that co square according to equation number 1 must be equal to co square according to equation number 2. That is to say, r square plus x square must be equal to b2 square plus h2 square. And repeat again, according to equation number 3, r square plus x square equals to b2 square plus h2 square. Then we created equation number 4 that states that do square according to equation number 1 must be equal to do square according to this equation number 2. That is to say, r square plus 35 square equals to b1 square plus h2 square. And repeat again, according to equation number 4, r square plus 35 square equals to b1 square plus h2 square. Then we subtracted equation number 1 from equation number 2. That is to say, we have here equation number 2 minus equation number 1. In equation number 2, we have r square plus 85 square minus equation number 1. In equation number 1, we have r square plus 33 square. And it is equal to this side of equation number 2 minus equation number 1. In this side of equation number 2, we have 2b2 square plus h1 square minus this side of equation number 1, that is b1 square plus h1 square. Then we open the brackets of this equation number 5, and found out that r square plus 85 square minus r square minus 33 square equals to b2 square minus h1 square minus b1 square minus h2 square. R square minus r square is 0. h1 square minus h1 square is 0. So from equation number 5, after we cancel those two expressions, we left only with 85 square minus 33 square, that is equal to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. In equation number 4, we have r square plus 35 square minus equation number 3, we have r square plus x square. Then we went to this side of equation number 4, we have here b1 square plus h2 square minus this side of equation number 3, that is b2 square plus h2 square. Then we open the brackets of this equation number 3, we found out that according to equation number 3, r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0, b1 square minus b1 square. Actually here h2 square minus h2 square is 0. So what is left from equation number 6 after we cancel those two expressions? What is left? It is actually 35 square minus x square equals to b1 square minus b2 square. Then we multiply this equation number 6 by minus 1. So here 35 square minus 1 is minus 35 square. Minus x square times minus 1 is plus x square. And here b1 square times minus 1 is minus b1 square. And minus b2 square times minus 1 is plus b2 square. So in conclusion, we found out that according to this equation number 6, x square minus 35 square equals to b2 square minus b1 square. And according to equation number 5, we already found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. Again, according to equation number 7, b2 square minus b1 square according to equation number 5, that is 85 square minus 33 square, it must be equal to b2 square minus b1 square according to equation number 6, that is equal to x square minus 35 square. So in conclusion, We found out that according to equation number 7, 85 squared minus 33 squared equals to x squared minus 35 squared. Then we added 35 squared to this equation number 7. We found out that 85 squared plus 35 squared minus 33 squared equals to x squared. 85 squared is 7,225 plus 35 squared is 1,225 minus 33 squared is 1,089, that is equal to x squared. 7,225 plus 1,225 is 8,450 minus 1,089, it is equal to x squared. And 8,450 minus 1,089 is 7,361, that is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. Then we took a root out of this equation number 7, and found out that x equals to plus minus the square root of 7,361. So here we will have two solutions that are possible for x, the positive solution and the negative solution. But because of the fact that x is a length, x as a length must be a positive number, so we take into account only the positive number. That is to say, x equals to 85.796 units. So the area, the length of this line segment x is equal to 85.6. It is equal to 85.796 units. Again, x equals to 85.796 units. We finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. So in the drawing we have a semicircle, AB equals to 6 units. AB is the diameter of the semicircle, that is equal to 6 units. Angle BAC equals to 30 degrees, and our mission is to find out the value of the area of the green shape. Okay, so first of all we define the center of this semicircle as O. The diameter of this semicircle is 6 units, therefore the radius must be equal to half of it. That is to say, it must be equal to 6 over 2, that is 3. So the radius AO equals to 3 units, the radius OB equals to 3 units. Then we join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. So in triangle AOC, side AO equals to 3 units, side OC equals to 3 units, that is to say AO equals to OC. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle that is equal to this angle must be also equal to 30 degrees. So in triangle AOC, 30 degrees plus 30 degrees is 60 degrees. Therefore this angle must be equal to 120 degrees, that is the sum of the angles in any triangle. Then I presented to you the formula for the area of any sector. Here we have this sector, sector A or B, that could be any sector. R is the radius of the circle that contains this sector, and theta is the angle between the legs of sector A or B. According to this formula, the area of this sector, sector A or B, will be equal to pi r squared, that is the area of the circle that consists sector A or B, times theta over 360 degrees. The ratio theta over 360 degrees will give us the relative percentage that this sector occupies out of the entire circle, and when we will multiply this percentage by the area of the entire circle, that is pi r square, we'll get exactly the area of this sector, sector A or B. So pi r square times theta over 360 degrees will give us the area of this sector, sector A or B. We implemented the new formula in order to find out the area of sector A or C. So I copy sector A or C here. This is sector A or C. AO and OC are both the radii of the circle. That is equal to 3 units. The angle between the legs of sector AOC is 120 degrees. So according to this formula, the area of sector AOC will be equal to pi r square first of all. R is 3, so pi r square is pi 3 square times the angle between the legs of sector AOB, that is 120 degrees over 360 degrees. 3 square is 9, so this expression in total equals to 9 pi, and 120 degrees over 360 degrees is 1/3. So this expression in total equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So actually in total, in conclusion, we found out that the area of this sector, sector AOC, equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. We have this triangle ABC, that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle ABC will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC according to the new formula equals to A times B times sinus theta over 2. We use this formula in order to find out the area of triangle AOC. This is triangle AOC, the deformity from the original domain. AO equals to 3 units, OC equals to 3 units, and the angle between side AO and side OC is 120 degrees. So according to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, so it is 3 times sinus 120 degrees. 120 sinus 120 degrees is square root of 3 over 2, all divided by 2. So in conclusion, we found out that the area of triangle AOC equals to 3 times 3, that is 9, times square root of 3 over 2 times 2, that is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. Okay? But what is actually the area of the green shape? The area of the green shape, it is very simple to see from the drawing that the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will give us exactly the area of this green shape. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units, and we have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. That is to say, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, the area of the green shape equals to 5.53 square units. We finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Again, the area of the semicircle minus the area of triangle AOC minus the area of sector COB equals exactly to the area of the green shape. I repeat again, according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of any semicircle is the area of the circle over 2. That is to say, it is pi r square over 2. R equals to 3, so pi r square is pi 3 square over 2. 3 square is 9, so this expression in total equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. And what is the area of sector COB? First of all, we have to find out the size of the angle between the legs of sector COB. AB is the diameter of the semicircle. It is absolutely a straight line. So we focus on the upper side of the straight line AB at point O. Here, on the upper side of AB at point O, the sum of the angles must be equal to 180 degrees. So which angles we have here? We know that this angle equals to 120 degrees, plus the missing angle in total must be equal to 180 degrees according to rule number 3. So the missing angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles on one side of the straight line. So this angle must be equal to 60 degrees. So I copied sector COB in a new page. This is sector COB that I copied to this page. CO equals to 3, OB equals to 3. They are both the radii of the semicircle. That is equal to 3 units. And the angle between the legs is 60 degrees. So the area of any sector is pi r squared times theta over 360 degrees. R is the radius of the circle that consists the sector. Theta is the angle between the legs of the sector. So we have already found out that R equals to 3 units. Theta is the angle between the legs of sector COB, that is 60 degrees. So according to this formula, the area of the sector equals to pi r squared. R is 3, so pi r squared is pi 3 squared. The angle between the legs theta equals to 60 degrees, so theta is 60 degrees over 360 degrees. So in conclusion, we found out that the area of sector COB equals to pi times 3 squared times 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi, and 60 degrees over 360 degrees is 1 over 6. So in total, all this expression equals to 9 pi over 6. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in the numerator we have in total 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. But according to the formula that I presented to you, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again in the formula, the area of sector of the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times root of 3 over 4 square units. And finally, we have already found out that the area of sector COB equals to 3 pi over 2 square units. Here, 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2 minus 9 times root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi, and therefore the area of the green shape, according to the second method, equals to 3 pi minus 9 times root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Repeat again, the area of this green shape, according to the second method, equals to either 3 pi minus 9 times root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.